Thank you so much. Today will focus on virtual reconstruction in cultural heritage as a prominent part of the scientific research, focusing on the open data and open science. I am an archaeologist, I am a digital humanist, and I want to start this tale from the end. I want to talk about our project, our involved in the Georgia project, telling the story from the end, from another project that we made as a laboratory, is the Villa of Livia. Because when we create a new virtual museum, a new piece of code, a new project to disseminate the project, we have something that is very important, a part that is very important, the lost lasting of the project itself. This project was a very important project hosted in the Roman National Museum in Rome, a very important place and a room with a very high technological and setup. But it was closed in June 2011 after 4 years of work due to problems of the preservation and maintenance. So it can happen, let's say. But after that, it was impossible to reinstall it because of technical problem. And so we needed to made a new version of this Villa of Livia application with two different projects, Flamina Reloaded, let's say, focused on the narration and on dissemination for the audience, and behind Livia's Villa, a more scientific approach to tell how the reconstruction was done, the scientific process behind the reconstruction of the Villa of Livia. Unfortunately, we encountered relevant reusability issues. It means that even if we had a publication, a hard copy of the Livia of Livilla project, and even if the assets themselves were made in a very accurate manner, unfortunately we were not able to understand exactly how this model was done. Why is it relevant for the Georgia project? Because if we don't store all the metadata, all the information regarding the process of creating a virtual museum, we are not able to reuse it in the future. So the reusability of the assets is a mandatory aspect of a new modern project of dissemination through new technologies. Because we can have the technology obsolescence of the data, okay, software will change during the time, but data and the scientific process, it will be still there, and the 3D assets that we can make, that we have made for the Georgia project, must be validated as much as possible in order to maintain their scientific value and also the economic value, because we know that in the future we will be able to reuse this scientific effort to recreate other virtual museums or other digital environments and so on and so forth. So, reconstruction is a task in the scientific approach that is very important. In archaeology, is very the base of the archaeological investigation. Try not to rebuild. When we work with the archaeological domain, we work with a world made of fragments. So we are able to understand some objects that are fragmented actually, just because they are part of something that we can recognize. So it's a fragment of a volute of a Carinthian capital. For that reason, rebuild is understanding. Rebuilding is understanding. We need to include the reconstruction process inside the scientific study. It's part of it. And we have to justify, to validate our process. In some cases, it's very easy to understand what is the link between what we have and what should be in the past, like in the Domus of Cecilius Jucundus. Here, the project was just to restore digitally the paintings of this Pompeii Domus. In some other cases, it's very difficult to understand how it was, starting from what actually we have. For that reason, virtual reconstruction can be dangerous in some cases. We can go in the black box effect. We have beautiful 3D models, but all the elements inside the 3D model have varying degree of reliability, but we have all together. So we really need something to analyze the context and to put all the objects together in the timeline, because we have also the palimpsest effect in the reconstruction field. The Colosseum, like we have now, but we can reconstruct different Colosseums. The one when it was done, built in the 1st century, or in the 10th century has a fortress of the family Frangipane in Rome. So a castle and a Colosseum. So different 3D reconstructions for the same context. So we really need to manage time and complexity. For that reason, we use a methodology, the extended matrix, that blend different tools that are already inside the archaeological domain, like the matrix of Harris, the archaeological drawings, the archaeological documentation. An example is the Tomb of Relief Observatory, where we made a 3D reconstruction and a 3D model of the tomb with a laser scanner, obtaining a digital replica of this very incredible site, and making also some reconstruction hypotheses about the color, about the shape, using different kinds of sources, images, analysis of the surface, and so on and so forth. So different sources combined to create the final reconstruction. It's a moment of study, the reconstruction. The same for the stratigraphy in 3D from an archaeological excavation. It's important to put together the matrix of Harris and the stratigraphy as a 3D model in order to create the reconstruction, starting from the archaeological record. In this case, the pipeline is very easy. It's very similar to the traditional archaeological pipeline, where we collect all the data on the site, we make the analysis of the stratigraphic analysis. We add a full digitalization of the context with all the relevant information regarding the stratigraphy. It means that we collect all the data about time in the context, in the monuments. This way, we are able to create digital hypotheses, first of all with color, just simple colors regarding different levels of reliability of the reconstruction, and after that, a realistic reconstruction, a representation model for the audiences, for the users of a virtual environment, a virtual museum. Another example is a big environment that was discovered at Rome for the construction of the modern metro line C, underground line C at Rome. Also here, the starting point is the digital replica, the acquisition of the 3D information on the site, and the contextualization of it in a digital environment to understand better how it was, how its likelihood was in the past, in a specific moment in time. Here, the starting point is the stratigraphy, the temporal analysis of the context, during the study, combining the sources and the 3D modeling together. So modeling as a tool to study better the context. So we have the digital replica and the virtual reconstruction. Digital restorations of the surfaces, in this case, a floor and a roof, and digital painting in order to create from other contexts the walls. So a big reconstructive record, okay, that we will use to deploy the final virtual museum, as explained by my colleague Bruno Fanini. But what is requested by the European community is to make the data fair or findable, accessible, interoperable, and reusable. This aspect of the research is very important because it allows to reuse the object. And why we can reuse the asset, the reconstructed asset? Because it is validated, and something that is validated will maintain the scientific value and also the economic value and all the effort that we make now to create it. It is one of the fairness is one of the principles of the so-called open science. The open science is a new trend in science for a new, more participatory research to conduct, publish, and evaluate scholarship. It increases the cooperation and the transparency between different researchers, institutions, and it leads to a more robust scientific result. And in turn, it generates a greater societal and economic impact. But if we, let's say, if we publish not only the results of our research, but also all the data that we collected, the 3D models, the sources we use, also even the virtual museum itself, all the data that's connected to it, how we can protect it in order to be reusable, but according to a fair and a correct approach. It's possible to use the so-called Creative Commons. That is a legal shield that we can that we can use to protect data in order to say that the data are, let's say, reusable also by the scientific community, but for instance, not for scientific, not for non-commercial not for commercial goals, let's say. Maybe we can state that no one can make derivative works from it, but in the case of science, it's exactly what we want, to have different reuse and study other people that will study again our data sets in order to create more scientific information about our case study. But the very important aspect is the share-alike possibility. It means that if we publish something online protected by this Creative Commons license, who will reuse it, for him, for her, it will be mandatory to use it, but to republish it in the same way she obtained it. So it's a sort of growing data set in the end. The more researcher we study the context, the more open data and assets we will have about it. Open source enables reproducibility, we say. So even from the analysis point of view, we have a more robust way to analyze data. We are able to replicate what others have done, and we allow others to replicate our work from a scientific point of view, making all the workflow transparent. And more than that, we gain credibility from a scientific point of view and academic point of view. An example of regards the EARCO project that was already cited by my colleague Eva Pietroni. the Archeo project that led to the publication of all the data sets of the project on the Zenodo platform. That is a European community founded platform that is a sort of a big memory for Europe. What you will publish here will stay here for 100 years because it's under the CERN institution and is very safe, even for very important situations, let's say earthquakes or others. So it's underground, well protected, and so it's a big memory for the European datasets, and it's a reference point for us, for the CNR, for the publication of the open science. And here we have the Cerveteri tomb of relief and the capital tomb with all the dataset with all the files here that can be downloaded and reused according to a specific license in order to improve the study of the context. And we are also as CNR the authors of guidelines for at national level, and that can lead to a correct use of Zenodo to publish the datasets. And it's exactly what it's possible to do with the Georgia case study. Thank you so much. Any questions?